In this video, I wanted to talk about the new Arduino Uno Q. So I just recently picked this guy up, and I was very excited about this board. Obviously, when Qualcomm bought Arduino, they've come up with this new board, which has a Arduino Dragon Wing SoC on it, and kind of bridges the whole SBC gap for Arduino. So it brings Linux and Arduino together. The cool thing about this, if you may not know, is that it has the custom, it's right here, has the custom Qualcomm chip. So that's a bunch of A53 cores, I believe. And I think it's not super like fast, I would say. I think it's equivalent to a Raspberry Pi 4, I think that's what other YouTubers were saying. So not super fast, but it actually has, at the back, has a STM32. So that is pretty cool because it has basically a real-time microcontroller, and it has obviously this SoC. Now, I think that there's probably a big debate already about this board in general, because the Raspberry Pi also offers the same thing, the RP2040, Raspberry Pi's own kind of chip, and then obviously the SoC on the Raspberry Pi. So what's the point of this board if that kind of Raspberry Pi exists, and it's not better in the sense of performance? But I think there's kind of probably some other things really interesting to me. First of all, it is that STM32. I think that chip itself, getting access to it, it's such a nice package where it's kind of already done, and it's already bringing Arduino's bits and Linux together, because Arduino itself has a huge community, and Arduino's a really great microcontroller. So I think that itself is a bit of an understatement that people aren't kind of considering. But personally, I really found that really interesting and exciting. So for me, actually, this was more preferred platform to develop my, projects on, and a very strong platform for even just any projects you want. So it could be robotics or, microcontrollers, and obviously AI is the main thing they're kind of advertising here, and I agree with it. It's a great platform. But yeah, equally, you could do the same thing with a Raspberry Pi if you manually set it up. So I am going to show you the interface and kind of the OS that it runs. So it is a fork of, I believe I was reading this on the instructions, it's Fedora OS, or I think it's FidoOS. I think it's Fedora OS, but basically a fork of that, and obviously it's based on Debian, I think. So I can't be too sure. So I do apologize on that, but it's basically a Linux distro kind of customized to their liking. When you boot it up, so I have just basically restarted from boot, enter my password, and you get the App Labs application that opens up. And App Labs is basically their own thing of, they're calling it bricks, but that's kind of the Arduino code, and they merge it with Python. So if I kind of hover around here and just show like object detection, so if I open this one up, it is obviously a bit slow. This is the 2 gigs model that I have, so that's worth noting. There's a 2 gigabytes of RAM version, and there's a 4 gigabyte of RAM version. I think this comes with 16 gigabytes of storage and 2 gigabytes of RAM. So just pause there for you guys to see the specs. And then the idea is obviously you can get a 4 gigabyte version. I did want to get that, but it was just not available. So to be honest with you, I just want to get my hands on this thing and kind of see what even the lower tier can do. 2 gigs is not a lot of RAM for sure. So here's basically, for example, an example they have for object detection, and it uses a camera, so you can hook up like a webcam. So I did that demo already. It's not fast. I must very much admit it's not fast, and the FPS was like, it was like less than 2, I think. So it was not really good, but that's an SoC thing, I think, and that's more of a software stack. So the bricks connect basically any Arduino code to Linux, and I'll just navigate and show you quickly the main file for Python. So that's what the main file for Python looks like, and they're calling a bunch of, from their own APIs, they're calling a bunch of kind of bricks to kind of load them up. They already have the video object detection kind of embedded into their system. It's not kind of like showing you what model it's running. I already have an idea. It's YOLO, so it's version of YOLO, but don't know which one. And you can kind of play around and customize it. To be very honest with you, I wasn't actually going to use the App Lab after this, because when I ran the demo, the performance wasn't great. So I kind of knew that, okay, this is really good for connecting, I think, different bits and pieces of the Arduino platform with Linux, and you don't have to do it manually. So they do it for you. So if I run a different like example, basically it's supposed to recognize, hey Arduino, and then the heart changes to something. Now you might be wondering, how is this all powered up and how do I connect kind of the keyboard, mouse, and webcam? And I'm doing this through my USB, my monitor's USB C cable. So my monitor acts like a dock because it actually has power delivery. So it has 90 watts power delivery, I believe, and it's powering the board. At the same time, I've connected peripherals with just directly to the monitor at the back. So now I have my keyboard, I have my mouse. I'm just going to plug this in. So, and obviously that's how I've been plugging in USBs. It's not like Raspberry Pi where you plug a USB and it registers by itself. You have to go and mount the USB in Linux. So just keep in mind that I think it's a very bare bones Linux distro, and that's pretty good because it keeps it lightweight. So let's run the thing again, and this time if I speak hey Arduino, I believe it will do some voice detection. I don't actually know if it's going to the cloud or not. Hey Arduino. There you go. So I literally spoke into the mic, and you can see it's yellow, so it's accessing it. So I'm going to do it again. Hey Arduino. There you go. And the heart lights up for the animation. So that's pretty cool. So it kind of shows you probably the first time an Arduino platform connecting to Linux, connecting to AI applications, and connecting to peripherals. Like it's a proper SBC, it's a proper desktop. So that is pretty nifty. In terms of my own kind of use, again, I was saying I was not going to use App Labs a lot. Maybe I'll use their interface, how to connect to STM32 behind the scenes, so I can kind of take advantage of that hardware. Personally, I just love the fact that it's an Arduino and I can connect in Arduino fashion, kind of, motors and servos and whatever actuators I need, and kind of control it with an STM32, which is actually a really good processor. So, I have this cool processor from Qualcomm. I think kind of bridge it all together. It's pretty cool. I love the fact the form factor is pretty small, so you could put this in, robotics projects and stuff. It's pretty nifty in size. Again, you get the best of both worlds. Again, low wattage. You can hook a battery to it, make it portable. So they've been kind of marketing it for industrial IoT applications, robotics, and AI. And I think it does kind of stack up. Again, depends on what you want to do. It's not a screamer, so you need to kind of understand what software you're going to run on it. I would recommend getting 4 gigs of RAM. I just got 2 gigs because it was the first available thing. Because these have been out of stock, I think, and they've been kind of tough to get. It has Wi-Fi, has integrated Wi-Fi, has this cool matrix LED thing. It's flashy, so you could use it for status updating or whatever, for application diagnostics, or if you want to take advantage of the screen or something. And then you have obviously the classic Arduino shield can go on it. It's just Arduino pins and stuff. And then you also have some connectors at the bottom, which they didn't. I was reading the manual for it. They do tell you obviously it has like MIPI lanes, and you can connect it to, I believe it's 2 cameras through MIPI, I believe. So that's it for me in this video. If you enjoyed that, feel free to subscribe, and I'll catch you in the next one. Thanks, everybody.